All right, so we just looked at how my personal car is set up with the lockup and the 3 solenoids. Um, and Cameron Store Converter Services does all of my stuff. Um, but I've also used on customer cars multiple different companies' stuff, right? So like Mark Mickey at M&M Transmission, um, Dave Klaput at Performance. I've used a plethora of Virginia Speed, um, Mike Graham, I think is the last name. Um, all very similar, right? Whether it be one main solenoid and then one external, or maybe two externals, or whatever, however they want to do it. So I'm going to show you, this is how it was programmed. Most recently, we were having a problem. We pulled 50 pounds off the back end of the car, and by doing so, it got it down to 3,200 pounds, and it brought it to 58.5% nose weight, 57.5% nose weight, because we were having a wheelie problem. So um, it turned into a problem turning the lockup on in low gear, right? I'm going to show you that. But it wasn't a problem when I had the extra 50 pounds on the back of the car. But already being as heavy as it is, I wanted to get as much weight out of the car as we can. Um, so that's kind of like step one of what the goal is here with with my convertible. Um, the ultimate goal here is to get it down to like 3,000 pounds so we can try to be competitive in some of the stuff that we do. But and I say that, don't think that I'm taking lightly of it. I mean, we just went 410 at 185, 100, almost 186 mile an hour, and it's 3,205 pounds. But it's I'm not downplaying the performance of it, and I don't want anybody else to downplay their performance of it based off of this video. Um, but what I'm saying is that we're, as drag racers, we're always progressing to try to do better and go faster and yada yada. So um, hopefully, probably over the winter or something, we're going to wind up doing a back half in the car, which should afford us an additional 100-ish pounds out of the back of the car. So with that said, it raised a problem. So we pulled the weight out of the car, and we went testing. And you can see up here it says Darlington 42824 test 7. So I'm just going to show you this. Here's some data logs. We were in Orangeburg 424, then we were in Darlington 426, then we were back at Darlington at 428. Okay, notice it says new bar angle. This was the original bar angle. This is the new bar angle. This is the same bar angle, yada yada. Tried a whole bunch of different stuff to make this work. The end result was it actually made me pay attention to what was going on with lockup. And that's why I'm making this video. So the way this was programmed in the most recent outing was lockup main was on at 1.9 into the run, had no minimum RPM because by 1.9 we're well above 8,000 or 7,500 RPM. Minimum engine RPM, is if it was to pull it down, would be 6,400, and the minimum gear for activation was 2, right? So it had to see second gear before it would actually hit this main lockup. Now, um, I also had it set to unlock during the shift, and then there was an amount of time that it was unlocked. So let's look at some data. All right, first thing, all right, the let me remove the comparison. So this is the most recent outing with the car. This is the way lockup is set up right now in the ECU. Okay, so let's look at what we have here. Let's get rid of the G meter. Look up. Let's get rid of these slip values. I got slip channels built. I made other videos on how to look at slip. So here's your RPM trace, right? The engine comes up. Converter rolls right around 7,700, right? So we're right in the neighborhood of 7,700, and then it starts to accelerate, right? And the shift happens out here. If you look, here's your shift, single out. This is where the shift was commanded. And now let's look at gear position. So there's the shift commanded, 1.705. Okay, let me just do this. There we go. A little bit easier to read. 1.704, right? The shift is commanded right there. The gear position, right, doesn't actually engage until 0.788, which is only 0.04. It's not, or 0.04. So it's not huge deal, the amount of delay that's there, but there is a delay there. Okay, now notice the shifter is moved into the second gear, but notice the RPM doesn't fall yet, right? So Here we're in second gear and now the engine starts to fall. Now, why is that? Well, there's a whole bunch of mechanical things that have to happen in order for all this to actually jive. But lockup is not on. Okay, so lockup was not on in low gear. Now, peak RPM up here, 84, 82. And then it falls down here to like 80, 200, right? So we drop about 230 RPM on the shift. Not enough, right? It's not fast that way. The converter's too loose. Now, this is not me saying that the torque converter's too loose. This is me saying that this torque converter's too loose without the lockup turned on. So we gave up a bunch of numbers in the 330 because of this, all right? So let's look at lockup main pressure. That's our lockup main activation. So I didn't turn lockup on until second gear, okay? So it doesn't hit until 2.0. Now this green line right here, this is actually lockup pressure, okay? So if we look at lockup, there we go. Lockup external one, where are we? There we go. Yeah, external one's out here, right? So all this right here is just the main lockup solenoid, that one that's on the side of the transmission back there, or towards the front of the transmission. So it comes up, so we command it here, right? It hits 200 into the run, and then we have an increase of pressure. So it's not an instantaneous change. And this is some of the things that we deal with. Customers call me and go, man, I got lockup programmed, and it takes 2/10 or something or 3/10 for it to actually hit. Well, yeah. But notice as pressure is building, right? Like we're right here, we're only 87 pounds of pressure. Look at that. Engine RPM starting to fall, right? So there's the peak of it. But engine RPM is starting to come down. And then once we hit full, the main lockup's full pressure, which is 162 pounds right here, right? So whatever, right around 160 pounds, we have a base RPM of 6,847 RPM. So two things I want to point out, side note, that I want to point out about lockup. The first one, if you pull a motor down too hard with lockup, you're going to see the inside parts of the engine on the outside, okay? The other thing, if you pull a motor down, what you don't think is too hard, but it does not to continue to accelerate after you pull it down, those same parts are coming out of the engine, okay? So this is one of those use with cautions. And again, I kind of want to interject with this video and explain that, like, this is information that a lot of people pay a lot of money for. I'm trying to help y'all out and explain how this stuff works, in an effort to save you time, money, and effort, I guess, but also show the advanced functionality of what you can do with Holley, right? So lockup one hits and it pulls the motor down. Now notice, look at lockup extension or external one is not on. So let's turn that on. That was the first solenoid in that little block that's in the back there. So notice pressure right here is 163. Now this one, notice the response time's a heck of a lot faster. Well, the reason being is that when you turn on that first lockup solenoid, or what some people call like the lockup arm or soft lock or whatever, it has to charge that whole circuit, right? So it has to come out of that solenoid on the side of the transmission, um, and in through, like, out of that hose, and then back to those solenoid valves that are on the side of the transmission, and then up to the cylinder. It has to build all that pressure. It takes a little bit of time, but once that pressure is built, and all we're doing is shutting off one solenoid, because again, it's a normally open solenoid, and we close it so that we can build more pressure. Um, Notice the response time is significantly faster, right? It's a lot more like this shifter right here. Okay, so lockup one external hits, and then look at what happens with RPM. Let me just do this. Get rid of that. Get rid of that. Get rid of that and that. Okay. So notice what happens. Let's zoom in a little bit. All right. So here we are, RPM starting to climb. Lockup one external, which is our second lockup solenoid, hits. And then lockup pressure jumps, right? So there's our lockup pressure without it on, right there. And then lockup pressure with it on. And notice what it does. We're at 7,272 RPM. All it does is lay flat for not even a tenth, right? I mean, we're only talking, 6 numbers before it starts to accelerate. So there's not a dramatic change because the jetting inside of that thing just wasn't right. You know what I mean? So we have this increased lockup pressure, but it doesn't really make a dramatic change. And you can see it in slip calculation as well. So here we are, where before the second stage of lockup comes on, there's slip second gear, we're at 3%, lockup turns on, and lockup 2 turns on, and we're at like 1.8%, right? So we didn't make a huge change, and this bounces around because this deviates a little bit based off of drive shaft speed. It's a math channel. But we really didn't take a ton of slip out of it, okay? It didn't make a dramatic change. So now with me re-drilling everything, the goal is to be able to turn on that lockup 1 back here, okay? And once converter charge pressure kind of rolls over, here's converter charge pressure, right? So once converter charge pressure rolls over, it starts to shove that lockup cylinder on. And then I can turn on external 1 and external 2 in low gear. Now let me show you an example of why this is important to use like a soft lock. Again, without a soft lockup or a multiple stage lockup, whatever you want to call it, you will probably experience some pretty bad problems, typically tire shake. And I'm here to say that we knocked the mirrors out of my car. We knocked the door locks out of my car. We shook the door so hard that it shoved it into the quarter panel and knocked paint off of the quarter panel. Um, Tire shake can be brutal. I mean, it knocked shit, 5 or 6 of the rivets out of the wheel tubs. Some of the tie filler panels that are in the back of the car. Tire shake is vicious. It breaks a lot of stuff. So soft lock is the move, right? So um, let me show you what happens when you can use lockup the way you want to in low gear. So let's go back here, and I'm going to show you a comparison. Now, with full transparency here, this run here went a 410 with a 108, and the run that we're comparing it to went a 422 with a 111 60 foot. So the G meter's down, yada yada. But this is a pretty good indicator, right? So now let's zoom in right here. It's getting a little bit confusing. All right, so let me get rid of some of this stuff. Let's get rid of slip, lockup pressure. Okay, whoops. Slip 2. There we go. So the straight line, the non-dotted line, is from the 108 60-foot pass, and the dotted line is from the 111 60-foot pass. And this is my x-axis G meter through the VPS, right? Now notice right out here, this solid line, we're still revving in high gear and low gear, right? But notice here, the lockup's engaged. So if we look, lockup main right here is engaged back here, right? And then let's look at lockup pressure. So there's that same curve that happens, right? Now notice what it does. It pulls the motor down from 7,631 RPM. We're still in low gear, down to 6,900, right? And look at what the G meter does. 2.34 G versus 2.02 where I'm at. Right now, right here, we're into second gear now with the non-lockup in first gear pass, right? Here we're at the 2.38 G. If we scroll over a little bit, I think it peaks the G meter a little bit higher. 2.44, 2.45. So we're at 2.45 G, and we're at 1.9 into the run. We don't see that again, and then it slowly tapers off, right? So you can see it's slowly tapering off. Now, the engine RPM is accelerating. You see it through here. Let me close this stuff so you can see it a little better. This red line here, there it is. There's the engine RPM. Now, that's not a shift, okay? I can show you. Here's gear position. Dotted line, right? So the solid line is for here. The dotted line is our comparison. So the shift doesn't happen until all the way out here. So this is still in low gear. The higher you can keep that G meter up for longer, the faster you're going, okay? So turning lockup on in low gear is a huge benefit as long as you kind of get it dialed in. Now notice it pulls it right back down to that whole 6,800 RPM range. And just kind of rolls on out. So if you look, 6,800 here, if we click out here, where lockup's on in second gear, 6,800. So this converter's, whatever you want to call it, stall, flash, whatever, is somewhere in the neighborhood of 6,800 RPM. So the goal here is to lock it up in low gear and to stage it, right? To stage it so that it doesn't try to shake the tires. So let's look at what happens with lockup and slip percentage. So the solid line, slip percentage is up the whole run, like the whole section of first gear, and that's because we got more power in it, right? So it slips a little bit more, right? We're at 40% slip there. There were 31% slip here, but look at what happens, right? Let's overlay this lockup pressure. Look at lockup pressure is just starting to hit, right? It just hits right there, and notice what the slip percentage is doing. It's on a big downward swing. Once we start getting up to here, again, this is still in low gear. We're down here to 2.4% slip. So let me ask you, here, 4% to 22% slip at the top of first gear. Which one do you think is faster, right? Here's the top of first gear in the locked up run. We're 1.06% slip. So what do we think is going to be faster? I think that locking it up in low gear is going to be faster. So hopefully this explains some stuff to you. If you want to make this thing lock up in first gear, you'd come on over here and just change this to minimum RPM or minimum gear for activation from 2 to 1, and screw around with all this stuff here with timers and whatnot. So this is a about as advanced look as I'm really willing to get into with lockup. If you guys have any topics you want me to cover, if you got any questions about lockup, hit them down in the comments. If you are interested in buying any of this stuff, like Holley Efi or anything that they carry, or any other parts that we're dealers for, check us out on the website at HCR Innovations, or shoot us over an email or text message or call, whatever you want to do. The website is hcrinnovations.com. And if you guys have any topics that you want me to cover, leave them in the comments down below, and I'll try to get to them as quick as I can. All right, see you.